Today's lesson is on looking at proving parallel lines and using corresponding angles and other types of angle pairs to show that lines are parallel. These are the converses of the original theorems. It doesn't change the type of angles that we're learning. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Likewise, if two lines are cut by a transversal so alternate interior angles are congruent, then the lines are parallel. If two lines are cut by a transversal so the alternate exterior angles are congruent, then the lines are parallel. If two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. The transitive property of parallel lines says if two lines are parallel to the same line, then they are parallel to each other. The example, if P is parallel to Q and Q is parallel to R, then P is parallel to R. A few examples. Example 1. Find the value of x that makes M parallel to line N. First thing to recognize is that these are not a direct angle pair, but here's what I do know. The angle down here is 72 degrees. These two angles are corresponding angles, so they're the same measure. Now I know that these two angles next to each other are linear, a linear pair. Angles of a linear pair are supplementary. We know that if they are supplementary, that the sum of the two angles have a sum of 180, so 4x plus 5 plus 72 degrees equals 180. Distribute the 4. We'll do the algebra steps next. 4x plus 20 plus 72 equals 180. Combine your like terms. 4x plus 92 equals 180. Subtract 92 from both sides. X equals 88. Divide both sides by 4. So x equals 22. Next example says prove the alternate interior angle converse without using the vertical angle congruence theorem. So what this is telling us is that we're going to show that given we have alternate interior angles congruent, the lines are parallel. So we'll write a formal two-column proof for this one. Start with a picture. Put some angles on your picture that you're working with. So we're going to be given alternate interior angles. That would be example. We're going to prove by example. Angle 4 is congruent to angle 5. We're going to prove that my lines, we'll call them G and H, are parallel. You can name your lines what you'd like. You can name your angles whatever angle numbers you'd like. So we're going to prove the lines are parallel. We'll make our two columns, statements and reasons. We always start with the given information. Angle 4 is congruent to angle 5. That is given. Step 2. What else do we know? Take a look at the picture. We know that we can't use vertical angles, so let's use some linear pair things. Angle 4 is, we want you to use angle 4 in the proof somehow to get this in terms of proving that we have congruent angles that are angles supplementary to each other congruent. So we're going to say angle 4 is supplementary to angle 3. And that's linear pair, so linear pair postulate. Our next step is going to say angle 5 is supplementary to angle 7. And again, those are 5 and 7, if you look on the picture, are linear, so same reason. That would be the linear pair postulate again. So then we know that if they're both supplementary to 3 and 7 are both supplementary, we know that 3 is congruent. Since forward 5 were equal and they're both supplementary to those angles, that means 3 is congruent to angle 7, and that's congruent supplements theorem. Which is angles supplementary to the same ones are congruent. And then we know that G is parallel to H, because if you look at your picture, 3 and 7 are corresponding angles. So that's the corresponding angles converse theorem. Alright, next example says in the diagram P is parallel to Q and angle 1 is supplementary to angle 2. Proof R is parallel to S. We will use a 2-column proof format again, although if it says a paragraph proof and you want to write it out as a paragraph, that would be okay too. Either way is fine. So we'll go ahead and do a 2-column. So our given information is that angle 1 is supplementary to angle 2. And our proof, R is parallel to S. We'll start with our given. Angle 1 is supplementary to angle 2. That's given. So if we know they're supplementary, we know measure of angle 1 plus the measure of angle 2 equals 180. That's definition of supplementary. We know since we're given in the picture that P is parallel to line Q, we'll know that angle 2 is congruent to angle 3. Because those are alternate interior angles congruent. Therefore, we know that measure of angle 1 equals the measure of 3. That's definition of congruent. Congruent means equal. So if we substitute in angle 2 for 3 in statement number 2, we get the measure of angle 1 plus the measure of angle 3 equals 180. And that's substitution. That means that angle 1 and 3 are supplementary. That's definition of supplementary. Sum of the two angles equals 180 is the definition. That's how we defined it. So then we're to our last step. R is parallel to S. And we know R is parallel to S because if angles 1 and 3 are supplementary, those are consecutive interior angles, so that would be the consecutive interior angles converse. The next one, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe below it. Explain why the top stripe is exactly parallel to the bottom stripe. Well, because we know, this is a simple one, it's not asking us to prove, it's just explaining why. Because we know that if we have each one is parallel to the next one, by the transitive property of parallel lines, that if S1 is parallel to S2, and S2 is parallel to S3, S1 and S3 are parallel, and you can keep going down the line using that analogy, so eventually you get S1 is parallel to S13. And then finally our last example, similar idea, each parking space in a lot is defined by two parallel lines, shows a common line with the next adjacent space. Why the left line is parallel in space 2 is parallel to the right line in space 8. And the left side is parallel to the right side, which is then parallel to the next one. Again, you can keep on going down the line. And so this one is going to be our same reason as the last one. This is the transitive property of parallel lines. And that's our examples for today.